A thin rod of length L has a uniform charge Q. Write an expression for the potential difference VB minus VA if points A and B are very close to the rod in comparison to the length of the rod. Here's our rod, here's our points A and our points B. So the first thing we're going to do is we're going to draw our electric fields at point A and point B. Point A is closer to the rod, so our electric field is going to have a greater magnitude than the electric field at B, since B is further away. And as we're changing our distance in between A and B, our electric field is changing, so that's what's going to be our change, which is our DL. So since our length of our rod is very much greater than the distance between the rod in point A, and the rod in point B, we can use the electric field approximation for a very long rod, which is this E equals 1 over 4 pi epsilon naught times 2 times Q divided by L, which is divided by R. So since our R is what's changing in our equation, because as R changes, so does the electric field. So we can say that the electric field is equal to 1 over 4 pi epsilon naught times 2 times Q divided by L times divided by X, since we're on the X-axis. Since the electric field between B and A decreases, we have to do an integral in order to find the potential difference. In order to find the potential difference, we have to use our equation delta V equals negative the integral of E dot dl. We only have an electric field on our x-axis, which is given by this expression, so Ex equals the very long rod approximation, and then we're only cutting on the x-axis. So we have E dot dl would just be Ex dx comma 0 comma 0. So then we can take the integral of delta V equals negative the integral of from B to A of Ex dx. So now we're left with VB minus VA, which is just the change in the electric difference, is equal to negative the integral of from B to A of 1 over 4 pi epsilon naught times 2Q divided by L divided by X dx. We then can move all our constants to the front, so we're just left integrating 1 over X dx, and 1 over X dx is this equal to ln of X. So we're left with negative 1 over 4 pi epsilon naught times 2Q divided by L, ln of X from B to A. We plug in our points of integration and we get negative 1 over 4 pi epsilon naught times 2Q divided by L of ln B minus ln of A. Then we divide by negative 1 and we get 1 over 4 pi epsilon naught 2Q divided by L ln of A minus ln of B, which is this equal to 1 over 4 pi epsilon naught 2Q divided by L times ln of A divided by B, which is this a log identity.